Same speed as my voice travels out. It's about the same speed as when you and I get on a jet aircraft and move across the Pacific. And so what that means is that when this earthquake occurs, I've got 2 hours, 3 hours, 4 hours before that event, before those waves come across, and I can begin to move people away. Now the other question is, why can't I swim in the tsunami? I mean, why does the tsunami? And part of it is that these waves, although they travel relatively slow, it's fast for you and I. And the second thing is that they have an incredible long period. And the waves can go out first. And you know, us curious humans can walk out to look at what's going on there, and then the waves will come back. This period, this process between going out and coming in is on the order of tens of minutes. And so these big surges of material as they come across, even though I might be able to bob up and down, they're going to bring so much material with us that I really don't have the ability to respond to these things. And so you can see that as these tsunamis begin to move, even though they're moving relatively slowly, they're bringing so much material, so much mass with them, that it's going to impact all the structures. And I think this event probably has better characterizations of those kinds of things than any we've had. How big is this event? This is 100 years of earthquakes. And so 1, 2, 3, 4, 5, 6 events. So in the last 100 years, this event sits right at this boundary. And so these aren't, fortunately, events that happen very often. So the recurrence rates are very slow, but certainly they have big impact on people and events. I'd like to backpedal a little bit in that the event in Haiti last year, at the beginning of the year, wouldn't even appear on this particular plot. The event in Haiti is down here at magnitude 7. There are tens of magnitude 7s every year. That event, though, even though resulted in a couple 100,000 people losing their lives because it was very shallow, and it was in a region which had very poor construction process up, and so there was a lot of damage. And so just because these are very big doesn't necessarily mean that other events, and in fact this Chilean event, there were only a handful of people that lost their lives in that particular event. Another way of looking and trying to put this into perspective, and don't worry, we're not too far from finishing up. This is the cumulative moment or the cumulative number of events that have occurred again over the last 100 years. And you can see that this event in Kamchatka, the Chilean, the Alaskan, Sumatra, and Japan, those events account for probably 80 or 90% of the total energy released from earthquakes in the last 100 years. So these are very, very large events. These little slight ramps here are all the magnitude 5s and 6s and 7s that are happening every day, but they don't contribute to the overall energy budget. And these super events are the ones that we need to take into account. I think I'm going to go here then. And so Bill talked about, and I was going to ask you, how long did you think the ground motion lasted? You said it lasted a long time. Did you put a number on it?
I would guess 2 to 3 minutes.
Okay.
Yeah.
Using those seismic waves that were generated, we can run them backwards and image the fault and watch the fault image and how it releases energy as a function of time. And this is a model by the group at Harvard. And again, this is my 450 by a couple hundred kilometers. And that imaging process images 1, 2, 3, 4, 5 subfaults from that particular event. Over the last 800 years, one of these would go, and then one of these would go, one of these would go. Particularly, the thing we don't understand is why this cascade or chain of event. Why did they all go? Why did they trigger one after another? But it leads to, rather than a single magnitude 8, a magnitude 9 event. This is, as a result of that image, this is how that energy was released as a function of time, and this is 200 seconds, and so you can see that the major part of the fault itself moved on the order of minutes. And so it continuously radiates energy. And since you were in Tokyo, you weren't very far away, so the waves don't have as much of an area to spread out, but a very long duration of faulting from these processes. I'm going to end here because I think I was given about 30 minutes. And we were over here in Japan, and I want to take us home back to the Pacific Northwest. This is the fault that broke on the 11th. This is the state of Washington and Oregon. This is the subduction zone along that. About the same scale. You see it's about twice as big in some sense. This part of the fault broke in 1700. It's interesting because it flooded rice storage facilities in Japan from the tsunami that spread across the Pacific. This energy has been stored for about 300 years on this fault. And listening to Yuri talk about preparation, I know that when I lived in Portland, I didn't have a backpack. I didn't have food. I didn't have water. And so we wonder how well prepared we are in the United States if a similar event, which will happen in the Pacific Northwest, occurs. Might not happen tomorrow, might be 100 years from now. But the question is, how do we learn from this particular event and think about our preparation and our designs so that we can recover from some of these great events like this? I think that's about 30 minutes, so I thank you for your time and opportunity to talk with you.
Thank you very much, Dr. Stump. And after two great lectures, we'll still have a 10 or 15 minutes, so we want to have the question and answer session for 10 minutes. So if you have any questions, please raise your hand and just stand out or let me see it. Go ahead, please.
Well, you were talking about how the nuclear power plants were built to withstand an age.
Yes.
So are the buildings, were they built to withstand an age, or were they just lucky?
Well, I think that the buildings in general did well. I think in the case of the nuclear power plant, the tsunami, because of the bigger earthquake, the seawalls were not tall enough to withstand the tsunami, so they were inundated. The tsunami did the subsequent.
But the buildings are just.
I think that yeah. So the design criteria in this case for this particular area was a little bit smaller than that.
Looking at the big earthquakes,
Yes.
can you look at those in the 60s as being a cluster? Are they related in some way? Are we now in the middle of another cluster with the?
Yeah, unfortunately in 1960 was just when the global seismic network was being deployed. And in those days, everything was paper records. And so you had a drum with a little squiggly line on it. And so the data couldn't be digitally processed. And so the kinds of things we can do today where we can take the digital, we can run the wave propagation backwards, only came in the 1980s as we moved to new kinds of instrumentation. So it's only by inference that we can say something, but I think many of these big events have subsections of the faults that break together. I think maybe you remember in 2004, the day after Christmas, the Indonesian event that happened in the Indian Ocean. That again, in that case, the fault was about the size of California. It's actually a bigger fault. It was 1,300 kilometers long, about 100 kilometers. In that case, parts of it broke, and then it stopped for a while, and then broke again. And the duration in that case wasn't 200 seconds. It actually was about 30 minutes that the faulting went on in that case. These are some of the things we're trying to understand about the dynamics of faulting, and we don't have the answers. They don't happen very often.
I saw on YouTube an eyewitness video of someone in Tokyo. He seemed to have some sort of an early warning system that actually counted down to the second that the earthquake started in Tokyo. And I was wondering, is that very widespread? Do a lot of people have access to that sort of thing?
There are two things. One is that if you're very close to the fault, just like globally, that means that the seismic waves are going to arrive very fast. And so you can locate the event, and you can make a preliminary estimate before any of the later arrivals. And in that sense, if you have instruments really close to the fault, then that information can be forwarded. And that early warning system is what you saw in Japan. It's interesting to note that in the recent budget negotiations, that part of the USGS program was cut. So no, we don't have it in the United States. There's research going on in that area. It's promising, but not funded. I didn't want to move it, but it was cut.
In the Pacific Northwest, they don't see very many small seismic events along the subduction zone.
Yeah.
But Japan sees them constantly.
Yeah.
And yet we still predict a large
event.
Mega event with a long recurrence. Why are the two subduction zones acting so differently?
Well, one is how strain is accumulated and released in the fault itself. So it has to do with the properties on the fault itself. In the Pacific Northwest, we do see a lot of events, but on the ductile part of the fault. And one of the interesting new discoveries is the lock part of the fault, we see very little energy. But in the last 4 or 5 years, as we've imaged below that on the ductile, there are earthquake swarms that go on for months. And they start in one end and they go down the fault to Northern California and come back again, and then 6 months later, they come again. They happen very slowly, so they don't generate seismic waves that you and I observe. One of the exciting things is that there probably is some coupling between that ductile part of the fault and the brittle part, and so when it does fail brittly, there has to be some coupling. It's a new research area, and so in Japan we see exactly the same thing on the ductile part of the fault. So stay tuned.
So do you think the Japanese people will increase their intake of catfish now?
Well, we humans have many ways of explaining things.
Well, I just wondered, you said you were watching TV over in Japan. Here, they kept running the tsunami footage over and over and over again. Was it the same there, or did they play off of that? They just...
You know, in the first day there was a huge amount of that, and that ran, pretty much nonstop. This year, there's a pretty limited range of how much was available in that first day, so you saw it all pretty quickly. The Japanese TV probably had more maps than they did here because it meant more to people in Japan to be talking about specific prefectures and cities and so forth. But then I think pretty rapidly in the Japanese case, it went more technical. That you began to see more charts and numbers and things like that than you did in the continually sensationalistic U.S. coverage.
You said after the business resuming as normal, but like in the following day was like the business and economics all stopped?
It really was significantly altered. It was interesting that first night walking along the streets, you could see some effects of the large number of people who had to stay downtown in Tokyo, whereas usually they'd be able to go home on the trains. They had to stay in their offices or in schools or things like that overnight. So restaurants were incredibly crowded. And by about 9 o'clock at night, there were a lot of restaurants that were out of food, so they were shutting down. ATM machines had huge lines in front of them. Japan is a cash society to a large extent, so people needed money, so that money was going fast. And for the 2 days after that, when I was still in Japan, going into a convenience store, there were just some foods you couldn't get. So usually they have a lot of prepared foods in the cases. Those were gone. And I've heard for several days afterwards you couldn't get packaged bread. Japanese people often have half loaves of bread or just a roll in plastic. That was all gone too. And the word from the government was that was all being sent to the north as relief supplies. So in the short term there were these immediate impacts on what life was like. But from everyone I've talked to, in Western Japan things were normal immediately. Things didn't change that much at all. And in Tokyo it was not long before they were back to normal life. One thing I like to stress to people, you hear a lot of stories about sort of panic buying in Japan. And they're long-term stories. In particular in Japan, there are lots of stories about panic buying of toilet paper. Because this seems to be the normal pattern. When there's a disaster, people go and buy toilet paper. Okay? And in fact, my wife will be embarrassed that I tell this story, but when Y2K came around, I said, I want to fill the basement with toilet paper, because this is going to be when I can bargain the best. Second choice is ammunition, but number one is toilet paper. And what I say to people about Japan is that what we take for granted is in America, we're all going down to Costco and buying a truckload of stuff and stuffing it in the huge storage area we have in our house. In Japan, people don't have room to store a lot of things like toilet paper. And in Japan, still a lot of people go shopping every day for what they eat. So that supply network where you have to keep having food and supplies brought in on a regular basis is particularly important in Japan. And explains why people freak out sometimes when they think, boy, tomorrow I'm not going to be able to get what I need.
How sure that is it that that will not have earthquakes?
We do have earthquakes. In 2009, 2010, we had a series of magnitude 3.5s, 3.7s. That there's some evidence it's related to disposal of water associated with natural gas. But historically, the record indicates that we don't have a big record of large earthquakes. Doesn't mean there isn't a record in the geologic record of moderate size events. As I said, the closest large events are in New Madrid in the Mississippi embayment, where from December 1811 to February 1812, there were a series of 3 events. There's some controversy about how big they are, but I think a number of us believe they're mid-magnitude 7s that were widely felt. There weren't very many people that lived in that area. We would have been in some of the orangey colors here, maybe the in terms of the maybe not quite orange to greens. Chimneys would come down and things like that here in Dallas. The interesting thing is we don't understand. It's in the middle of the continent. It's not at a plate boundary at all like we see here. And so the mechanisms there, it may be an old suture, an old weakness in the crust that used to be a plate boundary that isn't anymore. So that's one reason for this Earth telescope, is to move across the region to try to understand.
Any more questions? I have one more. Are building in Dallas earthquake proof?
We have an expert right here.
You don't have to worry about that so far.
So you'd like to close this event, and he's going to give us a little talk?
All right, thank you guys. And we're actually almost at the end. And just a closing note, the 2 lectures tonight will be available online later. The link of the movie will be available on our website, SMU Japanese Association at SMU. If you're interested, you can just search, for example, SMU Japanese, and you will see at the top of second, maybe you will see the link link on our website. So we will let you know about this. And I'd like to mention a little bit about our sponsors. One of them is the Half Price Books, Records and Magazine Incorporated. And actually, we are selling T-shirts. That's exactly what I'm wearing. And also, yeah. And all of them are produced by this Half Price Books company, and they funded everything for the T-shirts. And actually the last weekend we were out there. We were at the store out there, and we are selling the T-shirts. And we actually have a big sales out there. So we can't thank enough for them, everything. And I just don't forget to just stop by the stores and buy some books. That's what I regret, because I couldn't do it. I will do it later. And The another sponsor is ISEM, Institute for the Study of Earth and Man. This is the organization in SMU, and they actually created the monetary account, and all the money donated will be sent to their account, and they directly sent to the American Red Cross. So please give also the applause to them. And like I already mentioned, we are selling T-shirts, and these are still available outside of this room. So
just near the main entrance.
And this is $20 per each, and there are still enough T-shirts. So if you're still interested, please take a look and buy it. And we have also the another items for sale. Actually, we have the different organization from some people from different organization from the Mitsui company. This is also a Japanese company, and they are selling the bracelet for $5. Unfortunately, I haven't a picture, but they are probably already there. And please also take a look at them. And finally, hopefully this is going to be a fun time. We have a raffle.
Raffle time!
Make sure most of them have the seal number only at the shoulder or somewhere.
I love Japan stickers. There's numbers, and that's a raffle number. There are 5 winners, and the winner gets this cute doll. And the cute next one was this.
It is called Daruma dolls. Unfortunately, it's really hard to explain what it is. So I just copied the description from Wikipedia, so I just read it. Daruma dolls are seen as a symbol of perseverance and good luck, making them a popular gift of encouragement. The doll has also been commercialized by many Buddhist temples to use alongside the gold setting. So this is basically a talisman. So
yeah, so 5 of the people in this room are very lucky to get this Daruma, and the Daruma give you more luck. So luck of luck. It's very good, and
okay, so
Seismic.
duration. So we have 5 Darumas, so let me just pick 5 of them. 1, 2. Have a shot. 5.
5 winners.
Okay, the winners are number 21. And please count down and get 4. And the next winner is number number 32.
32,
Okay. And the next one is, oh, this is next to the previous one, number 33.
You need more shade.
Must be present to win.
Not there. Okay, so
As soon as you lose.
So the 6th man, number 16.
Number 16.